Hello everyone, in this video we are going to see about the memory allocation schemes. So this is an often repeated important question in a NET exam, and this is also a part of the important part of the memory management techniques. So let us see the allocation schemes, the first fit, the best fit, the worst fit and the next fit. Okay, so now let us see with the first definition what is the first fit and next fit. So here, as the name implies, actually we are going to allot the memory available space possible to the process or the job in the queue. The job should be allocated the process queue, then only the process can be done. So here, and again it also needs a memory so that they can occupy the process, they can occupy the memory space. Okay, so now in that scene we are having a first fit memory allocation. It allots the first available possible space. For example, a job of 10K is need to be allotted in a memory space, and the system sees first the 12K. That is the possible space. Suppose if it is 8K, it cannot allot the process. So now when it is available space comes, that is allotted, that is called as an first fit memory allocation. And here next fit memory allocation is the one. Here it is an extension of the first fit memory allocation, but the difference is that it doesn't search from the beginning, but it searches from the previous point. That means the system might have started from checking from the 0th position to the other positions, and the pointer might be somewhere in the intermediate level. Now this next fit will not search from the beginning, but it will always search from the previous point where the last search has been done. So that is the next fit memory allocation. And we have two more allocation schemes, best fit and the worst fit. Actually what is best fit is a job is allotted to a memory space which is closest to its size. That means the remaining space left after allocation is called as a whole. But here this best fit memory scheme, what it does is it allots to the memory block where the job size is little bit closer to the memory size of the job. In that case, it assumes that only a minimum of the memory will be wasted. That is called as an internal fragmentation. So that is the concept of this best fit memory allocation. And what is worst fit memory allocation is just opposite to the best fit memory allocation, in the sense that this will find out the largest memory block so that the process can be allotted. And what is the idea behind this is that even though a process is allotted to a bigger block of memory, what will happen after this job will be fit into that hole, the remaining space will also be larger enough to hold some other process that comes in the future. So that is the idea behind the worst fit memory allocation. So that's all the four concepts: first fit, and then next fit, best fit and the worst fit memory allocation schemes. Now let us see a question which is a question asked in the exam. So there a computer has 1000K of main memory, and the job arrives and finishes in the sequence. How the sequence is: job 1 first comes, it has 200K of memory size, and job 2 comes next, that is 350K, and then job 3 needs 300K. Okay, so now that's all. Now he actually just adding up these values, 200 plus 350 plus 300 is 850 KB of memory size. All the jobs J1, J2 and J3 has occupied. And what is the total size of memory? 1000K. So remaining 150K of memory will be left as a whole. Okay, so now the scenario changes. Now what is happening? Now actually 150K of memory is remaining. Now the job 1 finishes. After job 1 finishes, it naturally leaves the memory space. Okay, so that space will be left out. Now the job sequence goes like this: after job 1 finishes its process, it is leaving the queue, and job 4 arrives. That is the capacity, having the capacity of 120K, and then job 5 arrives, which has a capacity of 150K, and then job 6 arrives, which is having the capacity of 80K. So this is the scenario in a particular unit of time. Now the question asked here is, among the best fit and the first fit, which perform better for this sequence, because it depends upon the situation and based upon the memory space available, any algorithm may be best. Sometimes the worst fit may be best, sometimes best fit may be best. It depends upon the scenario. So now the question asked here is this, and the answer option here is first fit, best fit, both perform the same or none of these. So now let us find the answer for this question. So now coming to the scenario, just I have drawn the diagram of this allocation. So the totally 1000k of memory is available, and we have jobs J1, J2 and J3, and J1 is of 200k, J2 is of 350k, and J3 is of 300k. So they are allotted in queues, so the space are allotted continuously to all the jobs, and remaining 150k of memory is left out. So this is the scenario in the initial stage. Now what happens? After some time job J4 arrives to the queue, and then job J5 arrives, and then job J6 arrives. They have the memory capacity of 120, 150 and 80. And here we can see this is the calculation just I have given. The total memory size is 1000, and occupied space is 200 plus 350 plus 300, which is 850. So that is subtracted, so remaining is 150. So this 150 is the left out space in this time of unit of time. Now job J4, J5, J6 arrives, but when it arrives after J1 finishes, and the job J1 finishes its process, these jobs J4, J5 and J6 is entering the queue. So now the scenario is we have to find out during the first fit or during the best fit how the sequence is possible, which is suitable for the scenario. So now taking the scenario at time T2, this is happening now. Now we'll consider the first fit algorithm. In the first fit algorithm, the system always chooses for the first possible available space. Now job 1 is the first job allotted, which is having 200 capacity. It left the queue, so 200 spaces available. So when this job J4 comes to the queue, naturally this job size 120 is checked with 200k. It is possible to fit. This is the first thing available, so naturally the system allots this 120 of this job. That's why I have given this as the shaded part here. So 150 kb of the job is allotted to the 200 space of memory. So naturally this hole will be created, which is of 80k. Okay, so 200 minus 120 is 80. So this is left out after J1 left and J4 has entered the queue. Now then the scenario comes, J5 enters the queue. When J5 enters the queue, that is capacity is actually 150 kb. So when the system scans, this is also a first fit algorithm only, we didn't complete the first fit itself. So now the system starts scanning from the beginning. So here only 80k is left out. It is not possible for first fit because the job is 150k, but the available space first is only 80k. So system will go on searching for the space available, and this J5 was available. This 150k space was available. So the system will compare the capacity of 150 and this capacity of 150 space. It is enough to fit into the queue. So the job J5 joins the queue with the full capacity 150k. So now that's all. Now the whole memory is being occupied by all the processes. This is the scenario when the job arrives in this order, which is in the first fit algorithm. Now the same thing, let us check how it works with the best fit algorithm. So again, as usual, the T1 goes like this. Now at the time T2, we are going to apply the best fit algorithm. So what is the best fit algorithm? The system has to choose for the available space, so which is very closer to the size of the job which is coming inside the queue. So now this J1 left the job, so 200k was the available memory space. So what the system do is, it will just check for this memory space of 120, which is the available space of 200. But there are also other space which is 150, which is available free. So what it will do is, it will check which is closer to 120, 150 or 200. Only 150 is closer to 120. So the system will, this is the best fit algorithm. The system will decide it can allot the job J4 whose capacity is 120 into this whole 150 and not to the biggest hole 200. So nearest one is only 150k. So J4 is allotted to this 150k block. So naturally 150 minus 120, which is equal to 30k of memory, is left as a whole, which is not used for now. Now what will happen? Next the scenario changes. Now the job J6 comes to the queue. When the job J6 comes to the queue, what happens here? Naturally, it having the capacity of 80k. Okay, when it is having the capacity of 80k, here this 150 job is already allotted by this J5, so only 50 is remaining. Okay, so here, so naturally the system will allot. So this 150 already allotted as the first as the best fit. So naturally here this 50k will be left out, but J6 has the capacity of 80, which cannot be allotted. So only the space is now separated. Only 50k and 30k are available. So J6 cannot be allotted the memory for now, because the process cannot be broken into pieces to allot, because it is a contiguous memory allocation scheme. So naturally J6 doesn't find any space. So in the answer to the question, what you have seen is here the algorithm always the first fit is better, but the best fit is not better for this algorithm, for this scenario. So that's all, how to find out which algorithm suits which scenario. Hope you understood the concept behind the memory allocation schemes and also how to solve the problems over here, and thanks for watching.